All right, so let's look at some more sum and difference identities. You guys are going to have to help me out with some of these. So you definitely, if you missed class, you want to make sure you watch that derivation video 9.2-2 and look at how to derive one of these sum or difference identities. It was sine that it derived, correct? Sine of x plus y?
Yeah.
So let's apply them and do a couple more problems. So first, let's look at the cosine of 11 pi over 12. So that's something we can't do straight up from the unit circle.
11 pi over 3 minus.
Think about things you do know from the unit circle.
6 plus 3 pi
3/4 plus 1/6, is that 11/12? It might be. I just don't know. I'm going to have to think about it. So you're thinking 1/6 plus 3/4? 3/4 is 9/12. 2/12, is that 11/12? Yes, Mr. Freeberg has it. Let's do it that way. Is that the only way to do this? Probably not. There's probably different ways to get this. The problem, you know, I'm going to be a little careful with that. We do know things about 3 pi over 4 from the unit circle. Pi over 6, do we know?
Should have.
Do we know pi over 6?
Yeah, because it's
30 degrees, right?
Yeah.
So we do. You got to pick things that you know. I'm just making sure we're careful. Okay. So we can write this as pi over 6 plus 3 pi over 4. That's one way to do this anyway. Good deal.
Cosine and x plus y.
Right. Here's where knowing the identity comes in. If you haven't been watching at all with Calc 2, you should have seen how many identities we're using all the time. So that's the reason I'm having you do these. So cosine. Is cosine mixed sines and cosines for its identity that's a sum? Or is it straight up cosine then sine?
cosine x, cosine y.
It's cosine stuff,
And it's minus.
cosine stuff.
Minus.
And then does this stay the same or does it flip?
Flips.
It flips, yes. Sine stuff,
Sine y.
sine stuff. Yeah, I'm sorry. So now you just put the stuff in, right? So we say, okay, we put a pi over 6 here, and a 3 pi over 4 here, and a pi over 6 here, and a 3 pi over 4 here. That's the way I like my sum and difference identities. And then we're going to need a couple unit circle calculations, right? So I'm going to get those going over here. A good review before our first quiz next week. So pi over 6 is 30 degrees. You guys help me. What are the sides?
1, straight across like opposite, that means 1. And then square root minus 2.
Okay, and we need another one too. I'm just going to put it in the same triangle. We need 3 pi over 4. Where's that?
It's
4/4.
So
It's like 3/4, like that, right? How many degrees?
45.
bottom is negative 1. Oh,
That's not what
no, the bottom is negative 1. And then the
I'm just seeing. I don't know. So a lot of you guys I haven't even had before, so I don't know. And then you said this is negative. Anything else negative?
No.
No. Okay. Good. Cosine of pi over 6. So for that one, adjacent over hypotenuse is
3 over 2.
3 over 2. Cosine of the other one is
Negative 1 over root 2.
yes. Minus. Now we've got sine of the blue one,
1 over root, or 1 over 2.
and we got sine of the red one.
1 over square root 2.
So they end up with the same denominator, so it's okay. We're going to have 2 square roots in the denominator.
Good.
And we're going to have the negative square root 3, like next on the outside, minus 1.
And that's good enough. It's not rationalized because we've got a square root down here. If you want to rationalize it, the book might. I'll just show you. Clever one.
Yes.
So you'd end up with, what's that when you distribute?
Square root 6.
Negative square root of 6, yes.
Minus square root 2. Over 2, 4.
Over 4, very nice, because that's 2, and another 2 gives us
That's
4.
number 4 in the book.
Hmm?
Isn't that number 4?
I think it might have been in the book, yeah, whatever. But
That's cheap.
I made up the other ones, okay? Give me a break. Actually, I made them all up,
Oh, yeah?
but I apparently picked one of the book's examples. Okay, so let's look at this guy. I don't think you've seen one like this yet. Is there an identity, think about it, for the sum of cosecant of x plus y?
Yeah, there's 1 over the sine.
Right, but they didn't ever showed it to you before. Nice, okay. So this one's going to be 1 over the one for sine. So we just do the one for sine, yeah?
Sine x times cosine of 3 pi minus.
You guys following Parker?
Yeah.
Minus
Does
sine
this
of-
switch for sine?
Yeah. No.
It switches for cosine, but sine it stays the same.
Or plus sine 3 pi cosine pi or x.
Impressive, Parker. Okay, so is anything in there simplifiable? Sine is sine.
Yeah.
Cosine is cosine of x.
Cosine of 3 pi is pretty easy.
These are unit circle calculations.
Yeah.
So let's go to 3 pi on our unit circle.
-1.
1, 2, 3.
Negative 1 and 0.
And then
So this is
0
gonna
for
be-
sine. So it's going to be something plus 0.
Cosine is x.
So it's going to be negative sine x plus 0.
Sine is y. You guys are anticipating well.
Which is just negative.
That is the same as that. I'd much rather work with this without some kind of phase shift in it, even if I was just trying to graph. See, so if you were like really clever and you really know what's going on, and I asked you to graph something like that,
Just go to negative cosine.
if you really know how to do these fluidly, you might even just graph this because it's the same thing. That's a little far stretch, but it's possible. Let's prove one identity that I cooked up. That means it might not be true, so we'll see. I cooked it up a second ago, so let's try establishing this truth about x values.
Or this lie.
Or this lie, yeah, we'll disprove it if it's a lie.
I choose the left side. Definitely the left side.
Yeah.
I heard definitely the left side. I think that's a very wise choice. So we'll start with the left side. I'm not going to write it down again since some of you don't. Tangent. We haven't done tangent today yet. Can you help me with that?
Tangent.
You could do sine over cosine, but that's going to be too bad.
Tangent x, tangent y over 1 minus tangent xy, right?
So tangent x. Tangent is just like sine. You should have figured that out by now because their negative angle identities go together, so do the other kinds of identities in general. There's all kinds of matching in trigonometry because of the cyclicalness of the phenomena.
And we'll be working with that later too, won't we?
Yes. Oh, yes.
1 minus tangent pi times.
Okay, so we've got that. Right? Then we've got this.
I think it's 1 plus, is it?
You are correct, thank you, Luis. So then we're going to go sine is sine x. Cosine, it's mixed, right? Sine stay the same or flip it?
Same.
I think it does stay the same, you guys are right.
Yeah, that's
Sine pi cosine.
This isn't looking anything like that so far.
That kind of is.
No,
Really?
it will. You can see that it's
Okay, so we got pi in here, so I'm going to get my unit circle value for pi going right here. It's the same one we had at 3 pi a second ago, because those are coterminal.
Right now you just have a lot of cosine on the bottom.
So tangent. Tangent, you could go y over x on your unit circle there, right? So it's going to be 0 over negative 1. 0 over negative 1 is 0. I like to think about my graph. Sometimes on tangent, this time I think you want to go with that. So this is going to be 0. This is going to be minus tangent. This is going to be 0, so gone. Over 1. Oh, that just got simpler. Here, cosine is negative 1. So that's going to be negative 1. Sine is 0.
Which makes that whole thing 0.
Oh, so this is, go ahead, Derek. So this is going to be,
Negative tangent times negative sine.
yes.
You also want to take that little tangent and turn it into sine cosine.
It's going to be positive, yes.
which is just
will turn
that.
positive.
Yeah. Well, no.
That just here gives you that thing up there that we were trying to solve for. I don't know.
Oh yeah, okay. So I could have even written a more fun identity and said something like this, right? I could have put that there.
Yeah, that'd be.
I could have put that there. I could have kept going and getting more and more creative. This is how I create your test problems. Does that make sense?
You could also calm down.
I'm pretty hyper today, so I'll see you next time, guys.
Hedgehogs.